Welcome to this presentation that treats intelligent manufacturing systems, self-organization in the I4.0 contest. This article was submitted for IndusCon 2021. My name is Jackson Veiga at Universidade de São Paulo. This presentation will be structured as follows. The current reference about I4.0 presents a formalism for the composition of objects in the virtual world through the asset administration shell. In this sense, a submodel was described to represent the resource capabilities, and in the figure on the slide was demonstrated a flow diagram for checking capabilities using AAS. In this study, was observed the need for proposals that enable connections between resource attributes seen in virtual models such as skills. In other words, it's necessary an engineering tool with knowledge about process domain that know how to group these capacities. Therefore, the proposal of this work focused on presenting a new way of modeling functionalities for manufacturing systems, considering a proposal to deal with emergence by implementing self-organization or plug and produce in the context of Industry 4.0. This work intends to extract emerging project features, seeking to solve the gap described before. In this sense, it was defined a train of thought that support complex systems by adding self-organization in virtual research. The Evolvable Assembly Systems was observed in projects to develop technological solutions that implement these systems. Basically, the works related to EAS seeks to solve problems in aspects of component modularity. A better way to explain this technique is comparing these EAS characteristics with a Lego system. In both cases, there are any system related to the product composition. Instead of it, there is a set of pieces capable to form a product, and if we analyze this process, new products can emerge from pieces combinations by adding simple new functionalities. Now, let's come back for the manufacture field, where it was possible to observe the same aspects in a project called YAD. YAD means Instantly Deployable Evolvable Assembly Systems. The figure in slide better represents the YAD architecture that enables the development of solutions for virtual mechatronical components using the multi-agents paradigm. YAD was inspired by Kubasa project, that is the state-of-the-art for multi-agent systems in the context of distributed mechatronic entities. Kubasa means coalition-based approach for shop floor agility. Some particular features was extracted from these projects, seeking to contribute for this work proposal. By now, let's present one of the last features used to suggest the architecture modeling proposal. An agent was defining this work as an entity capable of abstracting information from real components, being a rational and intelligent element as it's able to make decisions based on perception. YAD has defined another architectural detail for agents definitions, which specifies two types of agents. Cognitive agent, responsible for applications, relationship, and interaction of motor agents, and motor agent, responsible for acting in the physical environment. Note that the aspects related to this last component we will not treat in detail in this work. Note that the concepts presented were not suitable to the Industry 4.0 context. Reason for this work combined the architectural features presented with an architecture that establishes the guideline for I4.0 resource standardization, being represented by the RAMI 4.0. That means the reference architecture model for Industry 4.0. This architecture standardizes and systematizes component I4.0 through techniques. Lastly, the resources I4.0 standardization makes possible by the concept of Asset Administration Shell, AAS. AAS composes the assets and the administration shell, enabling a formal description for mapping and extracting I4.0's data. Now that we have understood the work's basis fundamentals, only remains to apply technical considerations that has enabled the proposal. Using the reviewed concept, it makes possible to describe the virtual objects in I4.0 context. Therefore, an administration shell was specified allowing the representation of a product administration shell. Note that the workflow was suggested in case to enable process descriptions needed in a product manufacturing. These concepts are added with engineering based on capabilities. This means a general standard description for functionalities that may involve resource skills supported by a control application. The other side by this representation are presented by the resource administration shell that can be chosen by the workflow. These objects may refer skills with specific capabilities describing each service available in a virtual resource. One of the main attributes used in this work is the capabilities representation for grouping of skills. A skill is a specific functionality provided by an agent, which can also represent resource capacities. In literature, skill can be understood in several ways, according to the Herford context. This work has proposed a definition by grouping the software entity, modeling preference found in mass, and the proposal of I4.0. This resulted in the model presented, where also used the concept of simple and complex. A simple skill are easy to be identified because are directly specified in an administration shell. However, a complex skills are composed by different resource capabilities. The resulting skills can be supported by an intelligent system with reason characteristics to combine these functionalities. The composite level is treated as a skill set supporting coalitions and representing the workflow of the process. In addition, it was essential to apply an ontological definition for a set of skills, enabling to answer how to combine different levels of capabilities. In this sense, prepositions are made considering the EAS and I4.0 paradigms that treats coalition for functionalities of resource. Coalition represents many assembly systems that may be created by combining resource capabilities described in an administration shell. A better understanding was proposed by the diagram in slide, which represents three kinds of resource capabilities in an administration shell. The group C may refer to a simple coalition because it has only capabilities described directly in an administration shell. Therefore, the group A and B are complex coalitions for treating a high level of detail regard to resource skills. In short, simple coalitions are defined with direct relationship of capabilities in administration shell, and the complex coalition involves different atomic levels of capabilities that may emerge from a new skill creation in the control system. In this last case, mechanisms that describe ways to realize this relationship are necessary. This work proposal results in a suggested architecture model to cope intelligent systems enabling coalitions control, relationship, and self-organization of skills represented in an asset administration shell. Therefore, the company must follow the RAMI 4.0 guidelines, enabling the connection of a real resource to a virtual representation. This model has, at the bottom layer, legacy systems are described as resource and control device. In the next layer, it was proposed NAS concept by an agent motor that performs the integration between legacy systems and administration shell. The previous layers represents the real part of an I4.0 component. The Agent Communication Language, ACL, was suggested to integrate a real and virtual components in communication layer. The information layer is composed of three databases. First, for administration shell, second, for real device, and the last, for yellow pages. The functional layer is responsible for intelligent entities, representations, in aspects of mass control system. The main components are yellow pages, society of agents to coordinate and publish skills, mechatronic resource agent, and the leading coalition agent. The components described are in charge to offer reason and intelligent characteristics for administration shells, rise and pass. These last parts are understood in this work as passive objects making possible a standard description to different resource servers in I4.0 context. Let's understand now how these entities apply relationship. The coalitions of skills are enabled by a group of agents being responsible for assessing AAS models and joint capabilities flow mechanisms that are acknowledged by the mass extruder. The MRA agent is responsible to receive requests of capabilities from PaaS administration shell that describes the process workflow. This MRA must involve an agent coordinator CSA that is responsible for coalitions management supported by a contact definition in a YPA agent. The resources candidate must publish its capabilities. These tasks are made by an MRA agent that inserts the skills in a yellow page. The coalition process results in a relationship model that contains all capabilities objects identification. These must be controlled by another agreement that are constantly monitored and, if necessary, changes will be made. The complex skills are supported by an intelligent mechanism inside the cluster. The designate suggested allows the system to form and change its structure in I4.0 context. This is enabled by an intelligent system coupled to AAS, making it possible to assess skills seen as capabilities. However, in this proposal, AAS are in charge to provide or demonstrate service intentions by the engineering capabilities concept. The mass system, on the other hand, are responsible for establishing self-organization and relationship adding reason. Yarden Kubasa was validated as an ontological description for adding reason and greatly autonomy in elements developed from objects, conceived presented by components in the I4.0. The propositions made about engineering capabilities are according to the concept of skill and coalition. It can be a way to solve the gap of capabilities relationship. In this sense, adding a mechanism that enables coalitions of resource skills represented in an administration shell. Architectural considerations are at an early stage, enabling reflections on the paradigms proposed in the I4.0 guidelines. The purpose of this work is suitable for systems that require greater autonomy and decision making, where these last features were enabled with mass and EAS concepts. This work advantages the proposal of a mechanism to announce and group skills, similar to SOA, however implementing mass characteristics. This means incorporating cooperation and reasoning to create complex coalitions, enabling new functionalities, and updating it in AAS if necessary. The disadvantages in these concepts are related to the complexity of implemented systems, control, and reliability since it's a recent approach with a few practical samples for validation. Thank you, and now would be a pleasure to hear the comments.